Hello and welcome to another video looking at the wonderful world of flat earth and the things that they say. Well, for a while now I've been wanting to do something about perspective, so I'm going to do a couple of videos on this because perspective is something that flat earthers talk an awful lot about, and I must get told a few times a week by a flat earther that I don't understand perspective. Well, I do actually. It's flat earthers that don't understand perspective. They want to misrepresent it. And the reason they want to do that is because there are a lot of things that we see in the world that make a flat earth completely impossible. So they have to make up some bizarre excuses to try and get around this. And one of the ways that they do this is that they make up a lot of nonsense about perspective. So I thought I'd start by just having a quick look at the kind of things I'm talking about. p-brane did a video about this, so we'll just listen quickly to some of the stuff he said about it.
And then it hit me. What's wrong with this picture? What's wrong with this picture is that they are attempting to calculate visual angles to the sun from a non-visual, non-perspective drawing. So the drawing is not taking the visual perspective of the observer into account, and that's what's wrong with this diagram. You see, you cannot calculate visual angles to convergent positions, which is where the sun is from the observer, by using non-convergent parallel lines, which is what they're doing in the diagram here. They have two parallel lines and they're drawing visual angles to it. It's true that this drawing is an accurate representation of actual relationships and positions of the observer to the sun, but it's a non-perspective side view representation. So this diagram is not accurate at all as it relates to the perspective of the observer.
This pretty much encapsulates the kind of thing I'm talking about. And flat earthers have been making this argument for quite a long time, actually, right way back to the 19th century. They've been doing similar diagrams like this, which are just nonsensical garbage. When a person here looks in this direction, towards the sun, they do see things looking like they're converging. But you can't then look at that situation from the side like this and look at their perspective from the side. It doesn't mean anything. And I'll try and convince you of that. Now, another person who does something on this is this character, Brian Mullen, who's an engineer. And I'll be honest, I think this guy is an utter disgrace. He's an engineer, but he makes videos that are profoundly ignorant about physics and science generally. So he does the same sort of thing, but in this case, he's not... what p-brane's trying to explain is why the sun reaches the horizon, which you wouldn't expect it to do on a flat earth. What Mullen's doing is trying to explain why buildings disappear behind the horizon, which again, you just wouldn't expect it to happen on flat earth. So again, they have to make up this nonsense about perspective. And as usual, I'll provide links for these videos that I use. But I think I want to listen to just a little bit of what he says about here.
I drew an actual view, like a side view of what the perceived effect, line of sight from the theodolite would be for red pill world. So this is basically what he's seen looking.
Again, it's the same nonsensical idea that you can have a side view of someone's perspective like this. It doesn't mean anything. And hopefully by the end of both videos I'm going to make on this, you'll be convinced of that. Now he also has on here, I don't know if you can see that, it says to VP, presumably vanishing point. So again, he's making out that the vanishing point is a point out in space where everything in the person's view seems to converge onto a point. And again, that's just not true. That just isn't what the vanishing point is. So, I want to start with this diagram here. So, let's think about perspective. What's going on with perspective? Well, we live in a three-dimensional space. So we have objects distributed in the three-dimensional space around us. But an observer is just a point in that three-dimensional space. So everything is being viewed from a point in space to all the other objects distributed in the three-dimensional space around the observer. Now, we're going to assume that light travels in straight lines for this argument. It mostly travels in straight lines in reality. It doesn't always due to refraction, but mostly it does travel in straight lines. So I think we can safely make the assumption that light just travels in straight lines. It doesn't affect the argument, the fact that there's sometimes refraction. So this diagram shows a star here. It doesn't matter what it is. It's just an object in space, and here's the observer. So you can imagine the light travelling in a straight line right to the observer. Now this line here is what determines where something appears to the observer. Where something appears to us, where it appears in our visual field, is determined by angles and not by distances. So to determine where something appears, you need two angles generally. Now you can choose what they've got in this diagram here, the azimuth angle and the altitude angle. The azimuth angle is basically the compass bearing, which is an angle measured clockwise from north. The altitude is just the angle of elevation, which is the angle measured from the horizontal up the way. So you need two angles. Now the way our vision works means that anything along that line will look like it's in the same place to the observer. And that's crucial to understanding this. Anything that has both the same azimuth and altitude angle as that star will look like it's in the same place to the observer. Okay. Let's look at this, a similar diagram to the one p-brane was talking about. So you've got, let's presume it's a flat Earth. You've got an observer down here on the ground at the left. The sun at one point in time is here, and then later on it's over here on the right. So we can imagine the light travelling from the sun in straight lines to the observer. This angle between the horizontal and the line from the observer to the sun, as I said, you can call it the altitude angle, or you can call it the angle of elevation. But the further away the sun is, the lower that angle is. So when the sun's there, it's about 34 degrees. And then when the sun's there, it's about maybe 15 degrees. So the angle is dropping. So what flat earthers and people like p-brane want to try and convince you of is that, yeah, this is fine, this diagram is real and true, and these angles are fine, there's no problem with any of that. But on top of this, there's an extra thing going on called perspective. Well, no, there isn't. This is perspective. These angles are perspective. There is nothing else going on. And in this video, I hope to convince you of that. Now remember the point I was making, that anything along this line joining the observer to the sun will look like it's in the same place as the sun. So if I draw in lines from both edges of the sun to the observer, I could put in a smaller circle here, or a smaller sun. Now to the observer down here, this smaller sun will look exactly the same as the bigger sun here. It will be in exactly the same place in their visual field, and it will be exactly the same size. Now remember, when things move away, they start to look smaller. So if the thing moves away and gets bigger, it will look the same size to us. So if the sun started here, the big sun on the left here, and moved down and got smaller, it would look exactly the same to the observer as if it just moves away at a fixed height and stays the same size. So this sun here will look like it's in the same place as a smaller sun would be down here. Let's turn those off just now and put in another sun down here. So what flat earthers like p-brane and Brian Mullen want you to believe is that, yeah, there is perspective, but, sorry, these angles are correct, but there is this thing called perspective, which will make the sun, if it's here, look like it's down here or further down. That is total nonsense, and it makes no sense whatsoever. For one very simple reason. It would mean that when you look at something, the thing you're looking in isn't in the direction in which you're looking. Now that is completely nonsensical. Generally speaking, when you look at something, the thing is in the direction in which you're looking. Not always, because sometimes there's refraction, but refraction has nothing to do with perspective. Generally speaking, when you look at something, it's in the direction in which you're looking. So this idea that the sun somehow looks lower than it really is because of perspective is meaningless. Now let's think about what that might mean. Say, in a war situation, a gunner was trying to fire at an airplane. Well, the gunner doesn't aim at the airplane and then think, wait a minute, there's perspective to take into account, because perspective is making the plane look lower than it really is, so I should aim higher. No, they just aim at the gun at the airplane and shoot, because when they point the gun at where the airplane looks like it is, they're pointing at where the airplane really is. I mean, another way to think of this is if the observer pointed at the sun there and then pointed at the sun there, when they pointed at the sun when it was here, their arm would be higher than when it's here. And when you point at something, there'll be a line going through your arm that will extend all the way to where the object is. So this idea that there's an extra factor going on in this situation called perspective that's making things get closer to the horizon doesn't mean anything. It's wrong. Now another point to bring up here as well is this thing about the horizon. Flat earthers seem to think that the horizon has some very special significance in perspective, that what perspective is about is things getting closer to the horizon. It's got nothing to do with it. The horizon has absolutely no special significance at all in this situation. And it's just one of those things that flat earthers just want to confuse you with. Perspective has nothing to do with the horizon. Okay? Right. Let's look at something else. So let's think about why is it that they need to lie about this? Well, the reason they need to lie about this is because on a flat earth, as so many people have pointed out, the sun would never get as low as the horizon. Now, flat earthers claim that the sun is about 3,000 miles away, so we can represent the height as 3. On a flat earth, about the farthest away you could possibly be from the sun would be about maybe 20,000 miles. So that means that the lowest the sun could ever be in the sky on a flat earth is, I don't know if you can see that, about 8.5 degrees. Now that is well clear of the horizon. Now if you consider the fact that the sun has an angular diameter of about 0.5 degrees in your visual field, I think that gives you a sense that the sun would be well clear of the horizon at that angle of elevation. But what flat earthers want to say is, the angle of elevation is right, but perspective makes it look like it's lower. No, it doesn't. It doesn't make any sense at all. Perspective isn't some mysterious thing that your eyes do that crushes everything towards the horizon in your vision or something like this. It's just about angles and directions that things are in and light. That's all it's about. It's not mysterious. Right. So I want to consider this situation just to further convince you of this point, that these angles are perspective. Right, suppose you've got a situation where you've got an observer down here and they're inside a glass dome. Now, I know flat earthers will start getting excited. He's talking about the glass dome. No, I'm just talking about an ordinary glass dome, not the firmament. Nothing about flat earth, okay? Right, what I want you to do is imagine you're standing next to a window and you're looking out the window and you keep your head perfectly still, and through the window you can see something in the distance, whatever it is, a car, whatever. Now you could point to a place on the glass where it looks like the object that you're looking at is. So you could mark a point on the glass where the object looks like it is. Well, say imagine you've got an observer inside a glass dome and they're at a fixed position. They're just seeing everything from a fixed perspective. And they can mark somehow on the inside of the glass where it looks like something is. So what we've got here is, say you've got two lights, a red light and a green light, both at a fixed altitude above the ground. Now let's think about where they would appear on the inside of this glass dome to the observer. Well, all we've got to do is draw straight lines from the lights to the observer and then mark on where those points would be. So notice that the red light would appear here on the inside of the glass and the green light would appear here. The red light would appear lower than the green light because its angle of elevation is lower. And that's why things look lower in the sky when they're moving away. Okay, there's nothing else going on. There's no other fact. There's no other mysterious process called perspective on top of this. This is it. Right, let's look at one last example for this video on this. It's a kind of similar idea. Imagine an observer is here. Now it's a slightly odd idea, but suppose they're inside a glass sphere and they're at a fixed point of perspective, a fixed point in space, and they're looking down on a flat surface, and on the surface there are some lights that are evenly spaced out along the surface. So you've got a red, purple, blue, light blue, green, orange, yellow light along the surface here. Well, let's think about where would those lights appear on the inside of the glass to the observer. So if they were looking at those lights, where would they mark on the glass where the light appears? Well, all you've got to do is, again, just draw lines in. And then you can mark on the points. There we go. 7 of them. So we can zoom in. Okay, so to make it clear, I'll just turn the lines off just now. Right. So you can see that the places where the lights appear move up on the inside of this glass sphere from the perspective of this observer here. And notice something else. Remember, the lights were all evenly distributed along the line. They were all evenly spaced out. But from the perspective of the observer, they're getting closer to each other. And they look like they're getting closer and closer to a particular point. So to the observer, this flat line looks like it's moving up. I've turned it off, unfortunately. There it is. Okay. So this flat surface below them, although it's not moving up, it's horizontal, to the observer, it looks like they're moving up in their visual field, these points of these lights on the flat surface. And that's why we get perspective, because it's just the angles that things appear in. And it's because of two main points, really simple points. One is that where something is determined by an angle. And if two things are at the same angle to you, they will look like they're in the same place, because there will be a one line going from your eye through both objects. So they'll look like they're in the same place. And the other very simple point, which is when you look at something, it's in the direction in which you're looking. It's astonishing that that point actually has to be made, but I think it's indicative of the depths of dishonesty that these people have plummeted, that you actually have to say that. So anyway, I want to do another video on this, and in the next video what I'm going to do is have a look at what actually happens in your eye, and how your eye actually focuses the light and creates an image.